Hello everyone, this is Ferris,
Gabe.
Gerardo,
Amir.
and we are here to present Stable Point! The current problem we are trying to solve is the stabilization of projected augmented images within live performance presentations. This is currently a problem because the integration of augmented reality for presentations is fairly new and will often glitch out. Most users have only seen augmented reality in platforms such as Snapchat or Instagram, but when used in the right platform, can provide expedient amount of info and perspective. Our current solution to this problem is to develop an embedded tracking system and camera stabilization unit.
Thus, our problem will be split into two sections: the stabilization and localization of our camera and augmented images. For our second problem, the localization tracker, our goal is to determine where in the room the camera is at a given time. So we want to know the X, Y, Z position of our camera. We will use this process data to be implemented in the Unity game engine virtual environment to precisely overlay virtual content on the view of the physical scene. Through our research, we decided to use current tracking systems used in VR systems. So we'll be using infrared base emitters and photosensors on our trackers. The base emitter will provide a horizontal and vertical infrared layers in a room that will be received by our photosensors. In order to implement our embedded tracking system, we'll need to create a PCB board that has photodiodes that detect the VR lighthouse system. Once it is detected, the photosensor will then use amplifiers to amplify the weak signals detected from the photodiodes, and also use filters to get rid of any noise and unwanted signals before it enters the microcontroller. To be processed. Once processed, it will then update the VR lighthouse system about the physical location of the DSLR camera or iPad. We are currently in the works to implement this once we developed our bomb list.
The stabilization problem will be focused on the camera stability to prevent shaky videos caused by holding and walking with the iPad. We researched current camera stabilizers and decided to develop a 3-axis gimbal. The 3-axis gimbal will control our pitch, yaw, and roll through the 3 brushless motor on each axis. These motors will be controlled through our controlling unit, which is constantly receiving data from the gyroscope and accelerometer on the camera's position and the angle vectors. Amongst the 3 axes, we're currently done ample research on the gimbal and planning to be able to execute this, as well provide additional features such as zooming and focus, which will be useful for professional presentation.
So why we think our project is important? Maybe we all saw a gimbal before, and maybe we used it to get a vibration-free picture or video. Some of us might know about tracking system and how it works. Hologram technology is relatively new, and it will change the way we do presentation and allow us to present physical object in more dynamic and insightful way to the presentation room. You can imagine that an object can be as big as a car size object or as small as something you could put in your hand palm. Imagine how convenient is that. By combining gimbal principle and enhancing it with embedded tracking system, we can tackle that problem and lay the way to very promising technology that will change how we conduct presentation in the future. Thank you very much.
Currently, right now, we have most materials to begin construction of the skeleton for the gimbal, and it is currently waiting for us at our mentor's office. We will use labs such as the fabrication lab and the electronics lab to begin construction of this gimbal within the month.
As for the localization side of things, we have started ample research on the project and are in works of creating a bomb sheet for that. And with that, we thank you for your time. This has been Team 19.
See you next time.
Next time.
Thank you.